So, welcome all. Today we are learning something about multimedia. Basically, we would have heard about the technologies when we wanted to use audio and video. So, in past, what happened? We used radio for listening to audio broadcast, and we used televisions for this video program broadcast, right? So now we want to use our internet for these communication, right? Not only for text and image communication but also for audio and video services. So here today in this video actually we are trying to learn something about the applications related where this multimedia or audio and video services are used, along with the protocols which help us in the transmission of these audio and videos on the TCP/IP protocol suite based internet. So basically you understand audio and video, so we can divide audio and video services into these categories. Basically these categories are streaming stored audio video, streaming live audio video, and interactive audio video. So now in the first category, as you can see, it is stored audio video. So the files are actually compressed and stored in server. So it is compressed and stored on a server. Although in next slides also you will learn these things. When you talk about live audio video, what does it mean? It means something is happening somewhere, it is being transmitted. Okay, let me show you in the next slide. What happens actually, streaming stored audio video refers to on-demand request for compressed audio video files which are already stored on some server. Streaming live audio video refers to the broadcasting of suppose radio and television programs through internet. Okay, means these streams actually a user listens to broadcast audio and videos. Okay, for this we are using internet. Suppose you are one example can be suppose internet radio, right? So internet radio is actually the same radio program which is going on. It is also streamed on internet, right? So these broadcasts are considered as live streaming, right? Similarly, some any television program is also being broadcasted on internet, then those all the things are live audio video. The third category was okay, wait a minute. Interactive, where it is. So the third category was interactive. Interactive audio video refers to the use of internet for interactive audio video application. Some application where you can where both the parties or multiple parties can communicate. For example, video conferencing. Okay, so now this before these things audio or video signals can be sent on the internet, they need to be digitized. So suppose here we are discussing something about audio or video digitizing. Basically what I can say about digitizing audio means when a sound is fed into a microphone, you understand, an electronic analog signal is generated, right? That represents the sound amplitude as a function of time. So the signal is called an analog audio signal. Now this analog signal, it suppose you are thinking about any audio, right? So this analog signal can be digitized to produce a digital signal. Okay. So according to several theorems are there. So some theorems you will apply. There is something called Nyquist theorem. So if the highest frequency of the signal is f, suppose, what will happen? Suppose highest frequency is f. In that case, what we need is we need to sample the signal 2f times. Suppose this was your audio, right? So this is the highest frequency range. So if it was f, so we will sample this into 2f. Okay. So and accordingly we will give it some digital value. So then you will have these things as separate frames, and for all this you will have separate digital value which will be transmitted, right? So actually for voice, you see voice, actually you have 8,000 samples per second. So and here you will have 8-bit per sample, right? Per sample. Okay. So these all was for audio. So actually what will happen if you see these things, 8,000 samples per sample, 8-bit, in that case this will result in almost 64 kb per second. It is not only that 8,000 samples per second is something, it may change also depending on the application. Maybe for music it can be sampled very highly, like suppose 44,000 samples per second, and for each sample there can be 16-bit. So it may result in more requirement of more these things, transmission media, suppose 700 kbps, 1000 kbps kind of thing, right? Now if we think about video, so for digitizing this video we have to understand that we have frames, right? So in a video we have a sequence of frames. So if the frames are displayed on a screen fast enough, we get an impression of motion. So the reason is that our eye cannot distinguish the repetitive flashing frames as individual ones. Okay, so if these frames keep changing very fastly, then we do not understand that frames are changing. We understand that yes, really the real thing is visible, motion is visible. Okay, now there is no standard for number of frames per second. So 25 frames, some of the times 16 frames is also enough. Some of the times we need 30 frames or 50 frames also. So if depending on memory requirements also, number of, as you will increase the number of frames, it will take more memory. That is also thing. So each frame you should understand that it is divided into small grids. What happens, you should understand it as one frame is one image. It is divided into small cells. It will be called as pixels. Okay, this is one pixel. Okay, so for each pixel you will have some value. Suppose if it was a black and white image, so you will have to store just the gray value. So you will store some value between 0 to 255, right? This was enough. If it was a colored image and a color frame, then you will need to store 3 values, right? R, G, B, right? So now for R, G and B separately you will have 3 values, right? So for each pixel you will have 3 values for colored image, right? So that is what you have to understand. And suppose this is a story of one frame. The number of frames you will have per second, depending on that you will need that much bandwidth, right? So for that reason you may need to compress the image also, so you will apply some compression technique. So digitizing just means that you will divide this frame into pixels, and for each pixel you will have some digital value. Okay, if it is grayscale, some value between 0 to 55. If at all it is colored image, you will have 3 values between 0 to 255, right? Okay, now if we compression is needed to send video over internet. For compression you will see audio and video compressions separately. So you can understand about audio compression. Basically in audio compression what happens, we need to compress it, right? So we will apply some techniques to compress it. Some techniques can be, I don't know in next slide I have kept it or not, but it is predictive encoding or perceptual encoding. Okay, it will be predictive encoding and perceptual encoding. So MP3 is basically perceptual encoding. Now okay, so not going much detail of these things, but okay, video compression, it might be in next slide. Suppose images are there. For image compression you would have heard about JPEG, joint photographic export group, so it is used to compress image. Similarly for this was for an image. If you think about a moving picture, so many frames, there will be MPEG. Okay, let us see the JPEG process. So what happens in JPEG process, basically you will have this your block image, and then on it you will apply cosine transform, discrete cosine transform. है ना. Then you will apply quantization, and then again the data compression, है ना. So after after these three steps, cosine transform, quantization and compression, you will get some compressed image, okay, certain values, and it can be transformed later on into an image. Now uniform grayscale, okay, grayscale image will be like this. You will have certain value, no problem. There will be certain things about okay, no problem. These are the gradient grayscale image, no, nothing important. Okay. So this will be certain like compression things only. So suppose this was the transformed image, you will read it in this way, right? Keep it as the values, and these values can be transferred. On the other end, it can again be created the image, right? That is the thing here we are saying. The another MPEG comes here. So in MPEG you will have you know that it is moving picture expert group, okay. So it is used to compress video. In if you understand, motion picture is I should say rapid flow of a set of frames, okay. So when each frame is an image, right? So you can take it as a frame is a, I should say, a spatial combination of pixels, है ना? It has a lot of pixels. A spatial combination means they are related to each other. One pixel has a neighboring pixel as well. Now what happens? These you see the frames. So certain pixels may remain same. However, certain pixel values might change, right? So we will use these things, use this information while compression. So now this, suppose you are thinking about a spatial compression and temporal compression. The spatial compression of each frame is done with JPEG, you have seen, or maybe certain modification of JPEG. Each frame is a picture that can be independently compressed. Now there is something which is temporal compression, right? You understand that the redundant frames can be removed, right? Suppose this frame was same and this frame was same, there was no change between them, so this frame can be removed. We can understand. When we watch television, we receive 50 frames per second. However, most of the consecutive frames are almost the same. We understand, right? For example, suppose when someone is talking, right? Most of the frame actually is the same as the previous one, except for the segment of the frame around the lips are changing, right? So these lips may be changing from one frame to another. So temporarily compressed data, the MPEG method, what it does, it first divides frame into three categories. One is, you see, I frames, P frames and B frames. So here in this figure you can see the sample sequences of frames, okay, I, P and B. So here this I frame, what does it mean? Actually, I should say it is an intra-coded frame. Yeah. So it is an independent frame that is not related to any other frame. Yeah. So it is not related to either a frame sent before it or after it. है ना? So these frames may be present at a regular interval, I should say. Suppose every ninth frame is an I frame. Now this frame has to appear always, means after a period, maybe suppose it is 9th frame or 10th frame, so it has to appear there. Okay. Suppose when a video is broadcast, a viewer may tune at any time. So if there is only one I frame at the beginning of the broadcast, the viewer who turns in late will not receive a complete picture. So this I frame are independent of other frames and cannot be constructed from other frames. So basically this I frame will have more information, means the basic frame intra-coded, right? Other values might be changing. So suppose this iframe must appear periodically to handle some sudden change in the frame that the previous and following frames cannot show, right? So this will help the viewers to tune in at any time in the while the video is being broadcast. Now if we talk about the P frames, I should say it is predicted frame. Predicted frame. So in this predicted frame, what is happening, it is related to the predicting I frame. So each P frame contains only the changes from the predicting frame, preceding frame. What are the changes related to that? So the changes, however, cannot cover a big segment. For suppose for a fast moving object, the new changes may not be recorded in a P frame. P frames can be constructed only for previous I or P frame. P frames carry much less information than other frame types and carry even fewer bits after compression. Now if we talk about these B frames, so B frames can be considered as bidirectional frames. Bidirectional frames. So a bidirectional frame is actually related to the preceding and following I or P frame. So each B frame is related to the past and the future. So this B frame is never related to a B frame. B frame is always related to either I frame or it may be related to P frame. For this MPEG, what is happening? We have several versions. MPEG, I know only two versions. Two versions of MPEG. So MPEG 1 was there, which was designed for CD-ROM with a data rate of 1.5 Mbps, and this thing MPEG 2 is designed for high quality DVD, right? Data rate is from 3 to 6 Mbps. That is the only thing. Now, after knowing about these M frames, okay, these are something we are understanding about the relation between I and B frames. So let it be. Now we are talking about streaming audio and video. So let us see this in next video.